Hello guys, in this video we're going to talk about the chapter 1 which the content is all about geometric application of definite integrals. And chapter 1 covers volumes of solid, length of arc, center of a plane, and work. And now we're going to go through with the problems and the book of Feliciano and all related in these topics. And I'm going to give or select a problems and solve it respectively or in respect with these topics.
For this problem, we're going to find the volume of the solid generated by revolving the area bounded by the given curves about the indicated axis. So, y is equals to sine x is equals to 0, y is equals to 1, and we're going to revolve around y is equals to 1. Now, this is the graph of the function of the problem, and the object form will be like this. Now, since we are revolving around a horizontal line, we will use the washer method. The washer method is given by this formula. So the outer radius or the outer radius will be 1 to 0. So we have 1. So 1 is our outer radius. So r squared outer will be 1 squared. Then the inner radius will be from 1 to sine x. So we have 1 minus sine x squared. The b and a, or the limit of integration, will be x is 0, and to find the other limit of integration, so we equate these two. So we have sine x is equals to 1. So we're going to find x. So we have x equals to arc sine 1, and arc sine 1 is equals to pi over 2, or pi halves. Substitute those values from the formula to the formula. So we have integral of 1 squared minus 1 minus sine x is to 2 dx. And simplifying this, we can have pi 0 to pi over 2. So if we simplify this, we will have 2 sine x minus sine squared x. And we are going to integrate this separately. That integral of 2 sine x is negative 2 cosine x. And for this, we're going to use identity. So this will become integral of negative 5 times integral of 1 minus cosine 2x over 2x. So we can have pi times 1/2 x minus sine 2x over 4 from 0 to pi over 2. So substituting this limit of integration, so we have for the pi over 2 and 0, so we can have pi times negative 2 cosine pi over 2 is, or cosine pi over 2 is 0, minus negative 2. Cosine 0 is 1. Minus pi so pi halves times pi over 2 is pi over 4 minus 2 times pi over 2, so the remaining is pi, so sine pi is 0. So we have 0 over 4 and minus 0, so 0 over 2 minus sine 0 is 0. So we have this. Now the values will be pi times 2 minus pi times pi over 4. So the volume is 2 pi minus pi squared over 4, or 8 pi minus pi squared over 4. So this is the volume for the solid generated by revolving around the y is equals to 1. This problem wants us to find the length of the arc of the curve, following curves. So we are going to use the formula for finding the length of an arc. So length is equals to integral of square root of 1 plus dy over dx is to 2 dx. Now let's first find our dy dx. So dy dx is equals to the, so obviously the derivative of ln cosine x, so we have 1 over cosine x times derivative of cosine is negative sine x. So dy dx is basically negative tan x. Now let's substitute this negative tan x to the formula. So now the integral becomes L equals to pi over 3, 0 to pi over 3, square root of 1 plus dy dx is equals to negative tan. So we have negative tan x is to 2 dx. So operating this, we can have 1 plus negative tan x raised to 2 is just tan x squared x. So 1 plus tan squared x is an identity, and 1 plus tan squared x is equals to secant squared x. So we can replace 1 plus tan squared x into, or replace to secant squared x. So we can have just secant squared x dx. Square root of the square root of secant squared x will be just secant x. So now we integrate this. So we're left with L is equals to integral of pi over 0 to pi over 3 of secant x. The integral of secant x is ln secant x plus tan x. Zero to pi over 3. So substitute the limit of integration. So we can have ln secant pi over 3 plus tan pi over 3 minus ln secant 0 plus tan 0. So we have secant pi over 3 is 2, and tangent pi over 3 is square root of 3. Secant 0 is 1. Right, secant 0 is 1. So we have 1, and tangent 0 is 0. So now we have ln 2 plus square root of 3 minus ln 1 is ln 1 is just 0, so right here is 0. Then the length is actually ln 2 plus square root of 3. So this is the length of the curve. Now for this problem, our task is to find the centroid of the area enclosed or bounded by the given curve. So the given curve is x equals to 4y minus y squared and x plus y equals to 4. So the formula for finding the location of the centroid is just x mean, or the x mean is 1 over e integral of y squared, integral of x rather, from y1 to y2. Then for y mean is 1 over a integral of y dA. Now let us first find the y values, or the limit of integration. So let us equate two x functions, this and this one. So this will become x equals to 4 minus y. So we equate these two x. So we have 4 minus y squared equals to 4 minus y. So we have 4y minus y squared minus 4 plus y equals to 0. 5y minus y squared minus 4 equals to 0. So factoring this out, so we have y minus 1 and y minus 4. So our y values are y equals to 1 and y equals to 4. Next is to find the area and its derivative. So dA is just equals to x right, or the right x minus the x left dy. So our dA is just the 5y minus y squared minus 1. And our area is the integral of this. So integral of this is 5 so integrating this separately, we have 5 times y squared over 2 minus y cubed over 3 minus 4 times y. So if we substitute those limit of integration, 4 and 1, we can have 8 over 3 for substituting 4, and for substituting 1 can have negative 11 over 6. So this will become 9 over 2. So our area is 9 over 2. So now, by these values, we can start solving for x-min and y-min. So let's first determine the x-min. So x-min is 1 over the area. So area is 9 over 2. Integral of x. So the x here, since we have two x values, we are going to find the midpoint of that. So we're going to add the x here. We're going to find this x, the value of this x. We're going to add the 2x and divide it by 2. So 4y minus y squared plus 4 minus y over 2. So we have 3y minus y squared plus 4 over 2. So let's substitute this x to the formula for x-min. So we have the 3y minus y squared plus 4 over 2, and the dA is 5y minus y squared minus 4 dy. So let's multiply it to dA. So we can have 5y minus y squared minus 4 dy. So this is now the integral. Yes, for finding an x-min. So the integral now becomes 2 over 9. So let's get rid the constant here, the y 1 over 2. So multiply 2 over 9 by 2 for 1. So we're left with 3y minus y squared plus 4 times 5y squared minus 4 dy. So x-min is 1 over 9 and 15. This will become a distributive property. So this will become 15y squared minus 8y cubed plus 8y plus y raised to 4 minus 16 dy. Now we can have integrating this separately will result to 15 times y cubed over 3 minus 8 y to the 4th over 4 plus 8 times y squared over 2 plus y raised to 5 over 5 minus 16 times y 4 to 1. So the x-min is equals to substituting the 4 will result to 64 over 5, and substituting 1 will result to negative 44 over 5. So this will become x-min is equals to 12 over 5. Next, we find the y-min. So our x-min earlier is 12 over 5. So y-min is 1 over area, 9 over 2. integral of y dA. Since our given is those x values, so ry is just y. So y mean is equals to 2 over 9 or 1 y times the dA is 5y minus y squared minus 4 y. So y mean is 2 over 9 integral of distributing this y to 5y minus y squared minus 1. Result to 5y squared minus y cubed minus 4y. Integrating this will result to integrating this separately. So we have y mean is equals to 2 over 9 times 5 y cubed over 3 minus y raised to 4 over 4 minus 4 times y squared over 2, 4 and 1. So this will become over 9 times 32 over 3 minus 7 over 12. So y mean is equals to 5 over 2. So this is the location of the centroid. 12 over 5 is located in this side between 2 and 3, and 5 over 2 is between 2 and 3, so we have this. So this is the centroid of the area enclosed by the two curves. So this is 12 over 5 and 5 over 2. Then we're going to find the work done in pumping the water until the depth of the remaining water is 6 feet. So the height of the tank is 10 feet and the surface of revolution is formed by rotating y is equals to x squared. Now the question is, if the water is full of if the tank is full of water, then we will find the work done in pumping the water to the top of the tank until the depth of the remaining water is 6 feet. The height is 10 feet and the density of water is 52.4 pounds per feet cube. The radius is square root of y, 6 feet until it's 6 feet. So imagine it is full of water. This tank is full of water and we're going to pump out until the remaining water is just 6 feet. So the formula we're going to use is formula for work, which is given by this, the weight density and times the derivative of the volume of the tank times the height minus y. So that is the formula for work involving liquid density. So let's find the area. So the area y is equals to pi r squared, as all we know. So a of y is pi, since our radius is square root of y, so square root of y. So we have ay is equals to pi y. So our area is pi y. So area is pi 1. Now, the derivative of volume is equals to AY dy. So, the dV, or derivative of volume, is just pi y dy. So, we have dV is pi y dy. And now we substitute those values to our formula of work. So let's erase this one to gain space. So we have work is equal to integral of the density, weight density. So the weight density is given by Pg, the density times dV. So we have 62.4 pi y times h minus y dy. So since this is constant, we can take it outside the integral, or pi, and the remaining is y times h minus y dy. As we notice that h, or the height, is just 10, so substitute 10 to y. So now we can have 2.4 pi 10y minus y squared, and we can integrate this separately. So we have 10 y squared over 2 minus y cubed over 3, 10, 6. Now, substituting the limit of integration, or the 10 and 6, we have work is equals to 62.4 pi times 10 times 10 squared over 2 minus 10 cubed over 3 minus 10 6 raised to 2 over 2 raised to 2 over 2. So evaluating this, we will have 52.4 pi times this will become 500 over 3 minus this will become 108. So I'm distributing 62.4 pi, so we can have the work is 18,304 pi over 5 feet times pounds, feet-pounds. So this is the work done in pumping the tank until the depth of the remaining water is 6 feet.